All right, next question up. This one's going to be a doozy, but we've got this one here. So we're going to read the question sentence first, and it says, what was the speed for the second leg? Everybody, let's be very specific here. Yeah, we're looking for speed. That's great. But it's for specifically the second leg. We cannot let that piece of information go. So with that, let's go ahead and understand that if we are trying to find, again, the speed, which is the rate for the second leg, we need the distance for that second leg specifically and the time for that second leg specifically. When we read through the information, everybody, you tell me what you see. Does this problem tell me a distance, any distance at all? Does it give a distance here? I might see 330 miles and I might see 180 miles. So for sure, we absolutely do see distance. However, everybody, you tell me, are those the distances? Are either one of these the distances that I'm going to plug in right here? Yeah, the answer to that question is going to be no. It's going to be no. Because when we read this first part here, it says a trucker covers 330 miles total. Not the first leg, not the second leg, but total. And then the 180 miles, that refers to the first leg. So we cannot assume that, hey, we can use either of those, but instead we are going to use those clues to get the distance for the second leg. Everybody, you tell me, what operation are we going to do or perform if we have the total distance and then we have the first leg's distance? What are we going to do? Yeah, we'll subtract to get that distance. So let me go ahead and perform that right over here. 330 minus 180, 0 minus 0. I'll go ahead and borrow to make life easy. 13 minus 8, that'll be 5. 2 minus 1 is 1. So that distance is 150 miles. One step closer. Everybody remember your goal. It is the rate for the second leg. I still need to place the time here. If I can place the time for the second leg here, I'm good. The problem is I have the total time here, and I don't have the time for the first leg, but I can actually figure it out. Here's how. Distance equals rate times time. That formula right there. So I'll use my distance and my rate. My distance equals my rate times my time. Again, that's my first leg. And once we do this, we're going to go ahead, solve this by dividing both sides. So here we go. We'll divide both sides by 45. And my party people, you tell me, what is 180 divided by 45? What is that going to give us? If you're saying 4, you're absolutely correct. We can prove that right over here. 45 times 4. 5 times 4 is 20. 4 times 4 is 16. Carry that 2 is 18. So we're good. We've got that. So there we are. And so boom, our time period here is 4 hours. But here's the problem, everybody. We are not going to place 4 hours in here. Again, how do we find the time for the second leg specifically? We have 6 hours total right here. And then we have 4 hours for the first leg specifically. We'll subtract, exactly. So once we subtract, we have 6 hours minus 4 hours, and that gives me 2 hours. Booyah. Now I have everything I need to figure out the second leg's rate. Remember, everybody, it's all about consistency. If I want the second leg's rate, I need the second leg's distance, the second leg's time. That's what made this worth it here. And now what we'll do is set up our final formula. Distance, 150 miles, equals the rate that I'm looking for multiplied by 2. And so now what we're going to do is divide both sides here by that 2, and we're good to go. We're set. Divide by 2 on both sides. Cancel out the 2 on the right side. 150 divided by 2 is 75 miles per hour. And there we go. Our correct answer here, my party people, is going to be answer choice D, 75 miles per hour. So in this next question here, we see that it says how much more sugar do you need to buy? So, everyone, quick question before we really get into it. When we think about how much more of something we have to buy, or how much more of something we have left, what operation are we typically thinking of to find that gap, to find what is left? Yeah, typically to find out how much is left, how much more we need, that's going to be subtraction. Because if you think about it in the sense of, let's just take a quick little detour. If we say, hey, we have $6 and the game that we want to buy is $20. How much more money do we need? Well, that's going to be subtraction, and we'll get $14. So before I continue, does that little example make sense before we get into this problem that we see in front of us? Again, how much more of something that we need typically translates to subtraction. So now let's go ahead and get into it then. Let's delete this, and here we go. So a recipe calls for this much sugar. If you want to make 1.5 times that recipe, and you already have this much sugar, how much more sugar do you need? Okay, everybody. So to figure out how much sugar we need, here's how I'm thinking about it. It sounds like to me that if I want to find how much more sugar I need, we need to understand how much sugar we need in total, and we'll subtract how much sugar we have, and that will give us how much is left. Does that make sense, everyone? To get how much more we need or how much is left to buy, we'll figure out, hey, how much do we need in total? How much we need in total, and we'll subtract how much we currently have, and that's it. And we're good. So boom, if you already have this plan in your head, you're good. You already got it correct in principle. Now we're going to see if our confidence with calculation, it can follow through. Let's see. So here, to get how much we already have, well, we already have that. It's right here. We already have 1.75 cups. So boom, that's what I'll be subtracting, 1.75 cups. Now, how much do I need in total? Well, that's going to be given to us over here, where we say that a recipe calls for 2.5 cups, but we want to make 1.5 times the recipe. Everyone, what operation does that tell us to do? We have the 2.5 cups for one base recipe, but we're trying to make 1.5 times that. Yeah, that's multiplication. Again, the phrase times, that really gives it away. So let's get into it. We have 2.5 multiplied by 1.5. I'll go ahead and perform that right over here. And once we do that, we have 5 times 5, which is 25, carry the 2. Then we have 2 times 5 is 10, carry the 2 is 12. Next up, we are going to place a 0 so we can start multiplying right there. So we have 5 times 1 and 2 times 1. Add that back up, and we have 5, 7, and 3. Everyone, how many decimal places are we going to bring back? Yeah, in this case, we're bringing back 2 because we have 1 right over here and another right there. So we have 2 total. So we'll go 1, 2, and so that'll be 3.75. So there we are with that. Boom, let's move you over here. Well, let me go ahead and grab all of that. Perfect. Move you over here. And let's get the 3.75 where it belongs. Oh, look at how convenient that is, everybody. So with that said, 3.75 minus 1.75 conveniently leaves us with a final answer of 2 cups. Right there, that's how many more cups we need to buy. Because again, we need 3.75 in total. We already have 1.75. Subtract, and there's the gap. That's how much is left. 2 cups, which is answer choice D. And there we go. There's the next one in the books.